2.2 What is a solution? A solution is a homogeneous mixture of two or more substances. You come across various types of solutions in your daily life. Lemonade, soda water, etc. are all examples of solutions. Usually we think of a solution as a liquid that contains either a solid liquid or a gas dissolved in it. But we can also have solid solutions, alloys, and gaseous solutions, air. In a solution, there is homogeneity at the particle level. For example, lemonade tests the same throughout. This shows that particles of sugar or salt are evenly distributed in the solution. More no. Alloys. Alloys are mixtures of two or more metals or a metal and a non-metal and cannot be separated into their components by physical methods. But still, an alloy is considered as a mixture because it shows the properties of its constituents and can have variable composition. For example, brass is a mixture of approximately 30% zinc and 70% copper. A solution has a solvent and a solute as its components. The component of the solution that dissolves the other component in it. Usually, the component present in larger amount is called the solvent. The component of the solution that is dissolved in the solvent, usually present in lesser quantity, is called the solute. Examples 1. A solution of sugar in water is a solid in liquid solution. In this solution, sugar is the solute and water is the solvent. 2. A solution of iodine in alcohol known as tincture of iodine has iodine solid as the solute and alcohol liquid as the solvent. 3. Aerated drinks like soda water etc. are gas in liquid solution. This contains carbon dioxide gas as solute and water liquid as solvent. 4. Air is a mixture of gas in gas. Air is a homogeneous mixture of a number of gases. Its two main constituents are oxygen 21% and nitrogen 78%. The other gases are present in very small quantities. Properties of a solution. A solution is a homogeneous mixture. The particles of a solution are smaller than 1 nm, 10 to the power minus 9 meter in diameter, so they cannot be seen by naked eyes. Because of very small particle size, they do not scatter a beam of light passing through the solution, so the path of light is not visible in a solution. The solute particles cannot be separated from the mixtures by the process of filtration. The solute particles do not settle down when left undisturbed. That is, a solution is stable. 2.2.1 Concentration of a solution. In activity 2.2, we observe that groups A and B obtain different sets of solutions, so we understand that in a solution the relative proportion of the solute and solvent can be varied. Depending upon the amount of solute present in a solution, it can be called a dilute, concentrated, or a saturated solution. Dilute and concentrated are comparative terms. In activity 2.2, the solution obtained by group A is dilute as compared to that obtained by group B. Activity 2.3. Do this. Take approximately 50 ml of water, each in two separate beakers, and salt in one beaker and sugar or barium chloride in the second beaker, with continuous stirring. When no more solute can be dissolved, heat the contents of the beakers to raise the temperature by about 5 degrees centigrade. Start adding the solute again. Comment this. Is the amount of salt and sugar or barium chloride that can be dissolved in water at a given temperature the same? At any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is said to be a saturated solution. In other words, when no more solute can be dissolved in a solution at a given temperature, it is called a saturated solution. The amount of the solute present in the saturated solution at this temperature is called its solubility. If the amount of solute contained in a solution is less than the saturation level, it is called an unsaturated solution. What would happen if you were to take a saturated solution at a certain temperature and cool it slowly? We can infer from the above activity that different substances in a given solvent have different solubilities at the same temperature. The concentration of a solution is the amount, mass or volume of solute present in a given amount, mass or volume of solution. There are various ways of expressing the concentration of a solution, but here we will learn only three methods. 1. Mass by mass percentage of a solution, mass of solute by mass of solution into 100. 2. Mass by volume percentage of a solution equal to mass of solute by volume of solution into 100. 3. Volume by volume percentage of a solution equal to volume of solute by volume of solution into 100. Example 2.1. A solution contains 40 gram of common salt in 320 gram of water. Calculate the concentration in terms of mass by mass percentage of the solution. Solution: mass of solute salt equal to 40 gram, mass of solvent water 330 gram. We know mass of solution equal to mass of solute plus mass of solvent equal to 40 gram plus 320 gram equal to 360 gram. Mass percentage of solution: mass of solute by mass of solution into 100 equal to 40 by 360 into 100 equal to 11.1%. What is a suspension? Non-homogeneous system like those obtained by Group C in Activity 2.2, in which solids are dispersed in liquids, are called suspensions. A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Particles of a suspension are visible to the naked eye. Properties of a suspension. Suspension is a heterogeneous mixture. The particles of a suspension can be seen by the naked eye. The particles of a suspension scattered a beam of light passing through it and make its path visible. The solute particles settle down when a suspension is left undisturbed. That is, a suspension is unstable. They can be separated from the mixture by the process of filtration. When the particles settle down, the suspension breaks and it does not scatter light anymore. 2.2.3. What is a colloidal solution? The mixture obtained by Group D is in Activity 2.2 is called a colloid or a colloidal solution. The particles of a colloid are uniformly spread throughout the solution due to the relatively smaller size of particles as compared to that of a suspension. The mixture appears to be homogeneous, but actually a colloidal solution is a heterogeneous mixture. For example, milk. Because of the small size of colloidal particles, we cannot see them with naked eyes, but these particles can easily scatter the beam of visible light as observed in Activity 2.2. This scattering of a beam of light is called the Tendal Effect, after the name of the scientist who discovered this effect. Tyndall effect can also be observed when a fine beam of light enters a room through a small hole. This happens due to the scattering of light by the particles of dust and smoke in the air. Torch A, B. Path of light becomes visible. A. Solution of copper sulfate does not show Tyndall effect. B. Mixture of water and milk shows Tyndall effect. Tyndall effect can be observed when sunlight passes through the canopy of a dense forest. In the forest, mist consists tiny droplets of water, which act as particles of colloid dispersed in air. The Tyndall effect. Properties of a colloid. A colloid is a heterogeneous mixture. The size of particles of a colloid is too small to be individually seen by naked eyes. Colloids are big enough to scatter a beam of light passing through it and makes its path visible. They do not settle down when left undisturbed. That is, a colloid is quite stable. Table 2.1 Common examples of colloids: dispersed phase, liquid, dispersing medium. Type example: liquid, gas, aerosol, fog, clouds, mist. Solid, gas, aerosol, smoke, automobile exhaust. Gas, liquid, foam, shaving cream. Liquid, emulsion, milk, fish cream. Solid, liquid, sol, milk of magnesia, mud. Gas, solid, foam, foam, rubber, sponge, pumice. Liquid, solid, gel, jelly, cheese, butter. Solid, sol, colored gemstone, milky glass. They cannot be separated from the mixture by the process of filtration, but special techniques of separation known as centrifugation, perform activity 2.5, can be used to separate the colloidal particles. The components of a colloidal solution are the dispersed phase and the dispersion medium. The solute-like component or the dispersed particles in a colloid form the dispersed phase, and the component in which the dispersed phase is suspended is known as the dispersing medium. Colloids are classified according to the state, solid, liquid or gas, of the dispersing medium and the dispersed phase. A few common examples are given in table 2.1. From this table you can see that they are very common everyday life. Questions? Comment this.